Okay, yeah, welcome back. And yeah, this is the recording of my talk from the Netcentric Summit 2021. So my live session has broken up for whatever reason. Sorry for that. Hope that recording is good enough as well. So just fast forward to what you have not seen yet. So cloud native development is the topic that I would like to talk about. And what I normally like to do if I talk about a certain topic is to give kind of definition or find the definition about the topic to give a little bit of context and framing that we all know what we are talking about. The thing is that this time I don't have such a definition at hand. While I was investigating what cloud native development actually is, I watched a lot of videos and read blog articles, and I was not able to find the definition of that topic, which might be caused by the fact that it is a very young topic. But anyway, this is also not what I would like to clarify today. But we will come back to that question at the end of the talk to see what cloud native development is and what it could be for us and mean for us as Netcentric and us as individual developers and architects. What I would like to do today is to walk you through a little project, a small project that we were allowed to implement last year for Siemens, a pure cloud-based application. And I would like to talk about the challenges that we were facing, all the problems that we have, and how we have solved it. Yeah, and to be able to do that, we have to imagine the following scenario. Given is the requirement of a redirect tool. So a redirect tool to manage contents of a redirect. So not the performing redirects itself, but managing the contents round about redirects. Which domain on which path has to be redirected to which target. And is it a permanent or temporary redirect, things like that. In a perfect Adobe world, we would of course do that in AEM for valid reasons, because we have everything at hand what we need. A content repository where we can store our data. We have a proper group, user and group management in place to define which group of users is allowed to perform which kind of operation. We can search for our content, and we have a very powerful OSGI context in place. Container in place with Sling and APIs, everything that helps us to serve this tool to end users. And we know exactly what we need to do. And we write nice code. Everything is gold-plated, unit tested. Everything is fine. And we are just done within a week. Awesome. And now imagine someone is coming and saying, by the way, we don't do that in AEM. We will do it cloud native. In this case, our redirect tool idea, my super code, will feel a little bit lost immediately because all the nice things that I have mentioned are not there. So what do we need? We need a proper solution design, and this is where the first challenge comes in, because what we now have to do from a solution design point of view is we have to consider things that we are normally take for granted. User group management, content repositories. So this is normally all given, but now we have to walk through this cloud jungle and find all the bits and pieces that could support exactly these requirements and these functionalities to build up a proper solution design. So let's start. What do we need first? We need an HTML page that a user can request to interact with our tool. This is something we built within a SPA that will be deployed into an S3 bucket, and we use CloudFront content delivery network in AWS to serve this page to our end users, where we can also register a proper domain to. We need to make sure that only allowed users are able to access our page, and we also have to make sure that only a certain group of users can perform certain actions on our operation. This is what we use Cognito for, and the entire login handling will be done in Lambda at Edge to verify JSON Web Tokens and to handle login callbacks and all that stuff. Great. Now we have an HTML page in place that could be served, but we also need an API backend for our CRUD operations because we need to create, read, update, and delete redirects. As you have heard from Konrad this morning, we all will, or most of us will have implemented serverless function in 2022. So we did that already and used Lambda to implement our backend serverless. And these APIs will be served using an API gateway to the front end, also covered by CloudFront, to deal with course headers and have a proper subdomain for our APIs in place. So our backend API logic will interact or use DynamoDB to store data as our content repository. And while DynamoDB is great as NoSQL database to store data, and as long as you know what you're looking for, it is great to get this content out of the database. But if you do not know what you're looking for, DynamoDB is real slow, because searching in DynamoDB is not good. That's why we introduce an Elasticsearch as our search environment to provide search functionalities. We need another Lambda function to synchronize our content to the target engine, where all the redirects are being performed. And our customer also has requirements regarding some jobs to identify expired redirects or broken redirects, and the owners of those redirects need to be informed via email. Last but not least, we need to make sure that all of the resources that we have designed now can talk to each other. So, as you can see here, quite some resources that are required to get a cloud-native application running. So not only in AEM, but all the smaller bits and pieces that are required to get a fully fledged cloud-native app up and running. Great. So we have solution design now, and that means that we maybe finally can start writing some code and deploy it somewhere. Okay, let's give it a try. We use our famous Maven clean CQ deploy command, which will of course do nothing. So, and even if we would have used Java, what we didn't, this Maven goal would of course deploy nothing to nowhere, because, and this is also expected, and this is not a problem at all. I just want to say that the tools we currently use won't work in that cloud native environment. So what I also would like to say, we have noticed we didn't use Java because we are not restricted to Java anymore. And even more, you're sometimes forced to use different languages than just Java. So you remember the Lambda at Edge functions at CloudFront. Those can be implemented either in Python or in Node.js. So that means the cloud forces us to use different languages than what we have done in the backend until now, or as long as we work with AEM. So, and this is a challenge as well as an opportunity, and brings me to my next section, which is the tech stack. And we decided to go with Golang for our backend. Golang is a very great fit for cloud native development. Why? The compile time of our backend application is incredibly fast. So we get very small binaries in almost no time out of the compiler that could be easily uploaded into our Lambda functions in the cloud, and we can write very proper unit tests for our application. So that's a great fit. And at the end, as I said, we are not restricted to use Java anymore. And at Siemens, we got the freedom and the trust to try something new. That's what we did. And then we said, okay, let's give Golang a chance, and it worked very well for us. Our frontend was done in Vue.js, precompiled, statically hosted HTML, JavaScript, and CSS files that we deployed to an S3 bucket, and Node.js for the delivery, as I said already, for the authentication handling in Lambda at Edge functions. That's our tech stack, and now we have a solution design, we even have our tech stack, we have compilers, we can write unit tests, we can write code, we have everything in place, and that means we can maybe finally test our application. Yeah, but where? On localhost? Localhost, our redirect tool, even if written for the cloud, will still feel lost. Why? Why do I tell it? The thing is, local development is something, our point of view, that we can't use anymore. There are some tools like serverless.com that are able to emulate or mock certain cloud capabilities like CloudFront, an API gateway, Lambda functions, and DynamoDB. So this is great, and you would be able to implement something in local, but I can promise the first time you will raise a pull request, which is merged and then deployed into the cloud, your entire application will immediately fail. For sure, because all the EM permissions that are necessary to tell one resource to be able to interact with another resource is something that no tool can emulate. And you will end up in an endless loop, finding a bug, fixing it, raising a pull request, deploy, finding a bug, and so on until all of that has been fixed, and you will definitely go crazy. On the other hand, we permanently tell our customers that the clouds are very flexible and efficient. You just pay what you use. Exactly. So why not using those cloud capabilities also for the development phase? So that's why we have introduced developer environments in the cloud. So all the resources that we have seen in the solution design will be provided for each single developer individually, which helps to test certain changes in a branch completely isolated just for this developer without having an impact on other developers, other stages. So, and this is from our point of view, we should not spend any time anymore in getting local test environments up and running as long as we do implement for the cloud. So that does not make sense at all. But how to achieve that? We can, of course, now go into the AWS Management Console and click everything together. And I think after 4 hours and 10,000 of lost nerves, we will have something up and running, cool, which works on my cloud. Awesome. But we all can imagine that this does not scale. So how shall I transport this to the next developer for testing, for example? Shall I bring this to the next stage, dev, UAT, prod? And in our project, we had the challenge that we had to deploy the entire application into 2 different AWS accounts for 3 different stages and 3 different tenants. So we are talking about 9 environments across 2 accounts where our application has to be deployed the exact same way to each and everywhere. So I think you can imagine the solution for that is infrastructure as code to the rescue. So what we need to do, and this is the next big challenge and a big mind shift for our software engineers. What we need to do is not only write our business logic in Golang, having proper code in place, we also need to write our infrastructure as code. So there's definitely no option to separate that. If you write code, you cannot simply say someone else, now please write infrastructure around my code. So as I said, that cannot be separated, because why do I say that? We normally tend to write code, raise a pull request, and then someone else will take care of getting this code deployed somewhere. There are pipelines that I'm not aware of and I don't care. So if we are working for the cloud, then we have to do this. We have to write code to get the infrastructure required for my code, for my business logic in place, and initiate it and create it out of my local workstation the same way as we do it within our CI/CD pipelines. So infrastructure as code frameworks is something that we have a lot. So AWS, for example, comes with its own called CloudFormation. There's also something like Ansible and Puppet. So we use Terraform, which worked very well for us. So it's a very nice language to write infrastructure as code. Also from my point of view, it's very well documented. And that worked well. And as you see here, we were lucky because we were able to use GitLab. And what you see here is a CI/CD pipeline. It's our production CI/CD pipeline that helps us, or that we used or have introduced and have written to use our Terraform code and build our business logic and get it deployed into each stage for 3 different tenants. So, and the beautiness of GitLab here is also that, we have heard that we have to work with a lot of tools. So we need the AWS CLI, Terraform, Golang. We need Make to simplify our commands. We need the Vue.js, Node.js, a lot of tools, and creating one single slave EC2 instance, whatever, that contains all these versions is definitely a mess. So, and GitLab is very flexible here by using Docker containers. And what we have done here, we have introduced several different Docker containers for the different jobs. Not each job has its own Docker container, but there are combinations of certain tools, for example, the build backend stuff has a Docker container that has make and zip and Golang as a runtime. And the front end, of course, has not Golang but Node.js. And then later we get AWS CLI, Terraform, and that makes it very flexible and let all these stuff run in parallel where possible, which makes the pipelines incredibly fast. And we are able to set up such a whole infrastructure in a very short time to all the tenants and all the accounts in all stages. So back to the initial question. What is cloud native development? And as I said at the beginning, while I was researching about that topic, I read a lot of blog articles, but there was nothing really fitting. But the best thing that I found was a quote from someone from IBM who said, "Cloud native is about culture, not about containers." And I really like that quote because it's a mind shift. It's a cultural thing, how we can define cloud native, because it starts in our heads. What I would really encourage you is to think cloud. Next time you get a requirement and you work for a customer that already leverages the cloud and wants to use it, then do one step back, take a breath, and think if this requirement is something that could be done also in the cloud. So, and also vice versa, of course, the cloud is not the hammer for any nail, but please take the cloud into consideration if you have certain requirements to be realized. Next thing is the solution design, as I said at the beginning. So finding a sharp machete for the AWS or the cloud jungle, because all the clouds do provide a lot of resources, a lot of functionalities. Finding the right ones and sticking them together the best way, the optimal way, is also part of the culture. Same as the development. So we have heard that we have to change our thinking while we are implementing serverless functions, because caching behaves differently. We have cold starts, a lot of things that we normally do not have to deal with while we are implementing Java and AEM. And on top, we have this infrastructure as code thing that developers have to take over responsibility for their infrastructure, for their code. And at the end, we have to care about or work with modern tools to get our cloud infrastructure as well as the code compiled and deployed, flexible, quick, into different stages, accounts, and different ways of configuration. So all of that is, from my point of view, some sort of a definition of what cloud native development means. And I would love to discuss this with you in a new Slack channel called Cloud Native Development. So please join there. I would love to discuss ideas, problems, how we can solve certain challenges in the different clouds. And if you're interested in seeing what we have heard here today more in action, more in detail from a more technical point of view, then I really recommend to join the session from Jens next Thursday, a day in the life of a Siemens cloud developer, where you can see all this really working. And the plan is to start with a multi-day training session on March of 25th of March, where you can really get your hands dirty across several sessions to get your own cloud environment up and running. And last but not least, this is the team who worked on the project. So many thanks to this awesome team. So working with so many new things really requires to leave the comfort zone. This is what these guys did. We brought that project to a successful end. We learned a lot also in terms of things we can reuse in Netcentric. And many thanks also to you for watching now. And I'm always there for questions. Don't hesitate to reach out, join this channel, or direct message me. Thanks for watching. See you later.